We want to classify triangles as equilateral, isosceles, scalene, right angled, acute angled, obtuse angle, and so on. So let's see. Let's go through this example to classify triangles into their types. So before we begin, maybe a reminder of what these different triangle types mean. So equilateral means equal sides. So equi means equal. I guess this is a Greek or a Latin word. And lateral means sides. So equilateral is equal sides. So it's a triangle where all sides are equal. There is also another term for it, also called equiangular, which is basically saying that all the angles are equal. So that is an equilateral triangle. Isosceles means two of the sides of this triangle are equal. Scalene means all three sides are unequal. And then there is right angle, which means that one of the angles of this triangle is a right angle. There is an acute angle triangle, which means all the angles are less than the right angle. Or obtuse angle triangle, which means one of the angles is greater than the right angle, which is 90 degrees. So let's go here one by one. In the first example, this is clearly a right angle. It is marked with this right angle symbol here. We have to look for this symbol because it may look like a right angle, but it may not be a right angle unless it is marked as such. And maybe this is an important concept to clear here, that in geometry or in general for these types of problems, we cannot take for granted that something that looks like a right angle is a right angle, or two sides that are looking equal to the eye are equal. We cannot assume that. The problem has to specify what the actual angle is. If it is 90 degrees or 89.5 degrees, I cannot judge it just looking at it. Or these two sides, they may or may not be equal. If you mark them as equal, I'll understand that they're equal. So the broader point here is that as this is, geometry is a science of doing exact math or exact logic on inexact figures. So these figures can be inexact, or so therefore they need to be marked with what is equal and what is unequal, what is a right angle, and so on. So that was a slight digression, but I think it was worthwhile. So let's talk about the first figure. It is a right angle triangle because it is marked as such, and none of the sides are marked as equal. We'll see what that means in a minute. But here none of the sides have any particular equality with any other sides. So this is an equilateral triangle. Rather, this is a right angle triangle. And it's moreover a scalene triangle because all the sides are unequal. That's the first one. So let's talk about the second one. Here this triangle, all the three sides are marked as equal. So when you see a symbol like this on two sides, it means that those sides are equal. Here all the three sides are equal. So this is an equilateral triangle. There is no doubt about it. The third is an interesting example here. The two sides here are marked as equal. So it's an isosceles triangle, and moreover it's a right angled triangle. So this is a right angled and isosceles triangle. The fourth one is only an isosceles triangle because there is no right angle marked here. So this is an isosceles triangle. And looking at this triangle, it is clear that all the three angles are less than 90 degrees. Now here I am going a little against my own advice here that I provided a minute ago, that just looking at the triangle you cannot tell if it is acute angle or obtuse angle or right angle. You have to mark it because geometry is a science of exact math on inexact figures. But if someone were to ask you, just looking at this triangle and without any further information, is this an acute angled or obtuse angle triangle, then we say that okay, it is an acute angle triangle. There is no special symbol just like a right angle for obtuse angles or acute angles, but it is clear looking at this figure if we were to judge based on our intuitive understanding of what the angles are. In the fifth figure, this is again an isosceles triangle. And because this angle here is bigger than 90 degrees, so this would be a right angle. This angle is bigger than 90 degrees, so it is an obtuse angle triangle. An interesting fact that you might know from school or otherwise is that acute angle, or rather the isosceles triangles, have this special property that the angles opposite to equal sides are equal. So if I'm given an acute angled but isosceles triangle like this, these two sides are equal, then it turns out that these two angles are also equal. Let's call this triangle ABC. I know that suppose AB is equal to AC, as in this figure, then I know that angle ABC is equal to angle ACB. The sides opposite to equal angles are equal, or equivalently, the angles opposite to equal sides are equal. And therefore, in the extreme case of an equilateral triangle here, this equilateral triangle, all sides are equal, therefore all angles are also equal. And moreover, therefore, we know that the three angles of a triangle sum to 180 degrees. So each triangle would be equal to 180 degrees divided by 3, which is 60 degrees. So each of these angles here, this is 60 degrees, each of the angles is 60 degrees. So that was about equilateral or other different types of triangles, and you can also classify them based on the sides being equal or angles being 90 degrees or not. One important property of right angle triangles that I'll just mention briefly because it is so important is the Pythagoras theorem, which basically says that if you are given a right angle triangle, any right angle triangle with the sides, let's call them A, B and C, and let's say C is the hypotenuse, which is the side opposite to the right angle, then we know that A square plus B square is equal to C square. This can be proved, but I'm not going to do it right now, but this is an important property to remember. This holds for right angle triangles. Right angle triangles property. Okay,